from MIT, from the Sensible Cities Lab. Please can we welcome Carlo Ratti.
Good morning. Good morning, everybody. Can I have the slides? Yes. So I just want to share with you some of the work we're doing at MIT, looking at cities and technologies and new intersections happening between them. Now, if you look at this picture, this is something people used to be really fascinated in the 1990s, thinking about a world that would become increasingly virtual. So much so that somebody like Gilder, in 1995, the same year that Nicolas Negroponte wrote Being Digital, thought that cities would disappear. We're headed for a death of cities. Cities are leftover baggage from the industrial era. Well, this tells you how difficult it is to predict the future, because no prediction could have been more wrong than this. We know that over the past 20 years, cities have been exploding. China, this is a picture from Tianjin, is building more urban fabric than humanity ever built. And we know that half of the world's population now lives in cities, and that number is predicted to swell to 5 billion by 2030. So what has happened really is that digital hasn't killed physical space, but digital and physical are kind of recombining. We are covering our cities with sensors, with networks, with many other types of digital systems, and that is changing the way we can actually understand them or the way we can design them. Let me give you a quick example. If you look at this shows you how cell phone networks have been growing from the beginning. In 1979, we didn't have cell phones, believe it or not. And we've gone to 1 billion connected people, 5 billion. You might think, how much can this grow with 7 billion people on the planet? Well, if you look at Ericsson, according to Ericsson, predictions are like this: 2020, 50 billion connections. The reason is not that each of us will have 7 iPhones in our pockets, but the reason is that we started with something like this, connecting people to people, and then we moved to connecting people to data, and more people to machine to data, and increasingly machine to machine. Almost as if every atom of the physical world were becoming responsive, something we can engage, we can dialogue with, kind of a sensor and an actuator. Now, if this is what's happening, I want to share with you some of the projects we're doing both in the design office, where we look at architecture, and at the lab at MIT and in Singapore, divided them in sensing and actuating. In the first project, we looked at this computer. Today, you know everything about this computer. Every chip in it, you know where it was produced, how it moved on the planet, how it became this machine. We know everything about the global supply chain. However, a few years from now, when you throw away that computer, you know very little about it. Sometimes this is what happens to it. So we said, well, what if we put little tags on the trash? And then we start following trash. This was the first deployment we did in Seattle. 500 volunteers, 3,000 different pieces of trash. And after tagging all of them, we started following them. You see the day of deployment in Seattle. After a few days, a lot of this goes into the main landfills next to Seattle. But then a big surprise, actually, how far things started traveling. Nobody expected it. How much trash from the West Coast came to the East Coast. And and a lot of that in crazy ways, from Seattle to Chicago and then down to Baja California in crazy route after 1 month or 2 months. Well, we thought that was the music we needed. So what can you do with this when you know this type of information from cities? The first thing, if you are an engineer, you can actually get this information and try to optimize the system to save a lot of energy, for instance, by optimizing routes. The second thing is actually this data, if opened up with citizens, can promote behavioral change. One of the most telling things was somebody at the end of the project came to us and said, I used to drink water in plastic bottles every day and throw away the bottles and forget about them. Now, they go a few miles from home to a landfill, they will stay there forever, so I stopped drinking water in plastic bottles. The third thing we found out, and that was unexpected, happened more recently, just a few months ago, when actually a burglar came to our lab at MIT and stole a lot of things, including some of the tags that tell you where they go. And this is what happened. T-shirt with you. All right, I'm told I need to cut some slides because we're running a bit late. So, but imagine we can sense many, many things about our cities, and that allows us to better understand them, to design them better, and also to live in them in a different way. If we go back from sensing to actuating, how we change the system, you know, the easy way of actuating is sharing information. You know, that's a simple example. Uber as an interface gives you real-time information about the city, and then it helps you to interface and to change in real time, you know, your behaviors or things happening in the city. And when you do this, and when you start looking at this, you find out interesting things. Like in this project we're doing in New York City, we're looking at all the taxi trips in New York City and looking at what would happen if actually you were to satisfy the same demand for mobility in the city without increasing time for customers, but reducing the number of cars. And you analyze it with network science, and you find actually that the same demand for mobility in New York City could be satisfied with more or less 60% of the taxis we have today. So imagine the difference you could have on the city itself. Now, you know everything about the city. You now more and more know a lot about what goes on inside the car, sensors inside the car. Here's one example.
Finished the drive. It was incredibly stressful. It was the most stressful drive I've ever been on. Nevertheless, I think we have a lot of great content to measure road frustration, because I'm certainly frustrated at this point. And we're off. Jesus. God. Okay. Stop the car.
So we were just sideswiped. And right now my stress level should be through the roof. We got the information, you know, we'll have to process the data and see where it's really at.
Shit. Jesus.
Kyle is a student at the lab, so he had to jump after he crashed the car. But I got a few minutes less than expected, so I want to say you got all this information about the city, all this information inside the car, you combine them, and you get one of the things that will change our cities a lot over the next few years is self-driving cars. We got some of them at MIT, Google has one, many other companies and universities are developing some. And we got self-driving cars, everything changes. Because for instance, think about traffic lights. You know, you have a system without traffic lights where cars magically mix and intersect without bumping into each other. Now, don't try to do this today yet, but you know, this is what can happen then. And then, you know, the whole system becomes different. Well, I will skip this briefly, and I wanted to finish just with a couple of slides that we used to think that knowledge was something like this, that we could fit everything into the right spot. Still, St. Thomas' idea, when he wrote the Summa in the Middle Ages, that was the principle. Now, we know that knowledge perhaps is more like this today. That's a picture from nature. Taking 800,000 papers and looking at all the links, and look at the beautiful links where everything is connected with everything else. And the most important projects today, also, there's an article in Nature, are usually from many people coming from many disciplines. It wasn't like this just a few decades ago. Well, you know, in architecture, that was similar. Once upon a time, it was usually one person designing a city. That's Corbusier presenting the Plan Voisin for Paris, which was a simple idea. Basically, demolish the whole city, leave Notre Dame and a couple of other things as souvenirs from the past, and then replace everything with his beautiful new towers. Well, today, and people even say that, you know, you couldn't design collaboratively because, you know, too many cooks spoil the broth. A camel, so the saying goes, is a horse designed by a committee. So you couldn't design with many people together. Well, we think today is changing. Today we've seen Wikipedia, we've seen many examples, we've seen OpenIDEA, we've seen many examples of people coming together to solve problems together. This is an article in Domus recently that for an issue about open source architecture. And I had to write the editorial for this and say, well, why don't we do it together again on Wikipedia in a collaborative way? And you know, and that has started a number of additional things in how we can actually design together what we heard this morning, how creativity can come not just from one person like Corbusier in the 1920s proposing his plan, but in a more open and accessible way. And you know, at the end of the editorial, this we wrote together on a platform. Many people contributed, like Hans-Ulrich Obrist, like Nicolas Negroponte, and so on and so on. But Domus, at the end, still wants a picture of somebody who did the editorial. And we say, well, which picture should we add there? So we decided, well, let's put a picture with all of us combined together. And I wanted to finish with this because I hope that tomorrow's architects and designers and planners and engineers will be at least a bit less like Corbusier with his can, proposing his designs for the whole of Paris, and a little bit more like this, like a designer that represents all of us. Thank you.